Inductor. In this video, we are going to know about inductor. So, inductor, which is denoted with L, inductance. Okay, inductance. What is inductance? Inductance. So, inductance is a property of the material which opposes the change in magnitude or direction of the current. Okay, let's see here. Inductance Inductance is a property property of the material which opposes the change in magnitude or direction of current flowing through it which is known as the inductance. So inductance is denoted with by capital letter L, and units is Henry. Units is Henry H. Okay. Inductance is a property of the material which opposes the change in magnitude or direction of current flowing through it or flowing through the material We can use any of the sentence. Okay. Now, which is denoted by L. So, the inductance, like how the resistance is denoted with R. Resistance is denoted with R, like that the inductance is denoted by L, which is what is the letter L, and the units of this inductance is Henry. While coming to the units of the resistance is ohm, like that, like ohm it is Henry. And while coming to the symbol of the inductor, what is the symbol of the inductor? Symbol of inductor. So, symbol of the inductor, it is a when suppose if you take a conductor, if you take a wire or copper anything, if you twisted the conductor or that copper whatever it is, if you twisted it, then it resembles the symbol of the inductor like this. See here, if you twisted like this, understand, this is the symbol of the inductor which is denoted with L. Okay, A B. Okay, let's take the circuit, inductor circuit. So this is the inductor circuit. This inductor circuit is connected to a voltage source V, voltage supply V. So the current I is flowing through the circuit. I is the current flowing through the circuit. Now what is our statement definition for an inductor? Inductance is the property of the material which opposes the sudden change in magnitude or direction of current. So change in current means it is a DI. Change in current. Change in current is DI, which is done with respect to the time because it is AC. Okay, DI by dt. Okay, which is directly proportional to the applied voltage. Voltage is the force which makes the electrons to move in the inductor. So V is directly proportional to di by dt. So very important expression, V is directly proportional to di by dt. Now to remove this proportionality constant, we are going to add the inductance as a constant. So V is equals to L into di by dt. So which is known as the voltage equation. What is that? Voltage equation. Voltage equation. Now what we are doing from this voltage equation, we are going to find the current equation. What is the current equation of this particular inductor? So from this, if you want to find out current, di is equals to, from this equation you can derive this one. So 1 by L V into dt. See what happened, this L will come this side, okay, dt will come this side, then it will become like this. You know, from this how can we derive the current? So I is equals to integration of di. Is it right? So from this you have to do integration of dA is equals to integration of 1 by L V into dt. So here 1 by L is constant, so you can take I is equals to 1 by L integral V into dt. So this is the, sorry, from minus infinity to t. So this is the current equation. What is this? Current equation. So this is the current equation. Then what about the power? Power dissipated from the inductor. So if it is a ideal inductor, the power dissipated from the inductor is 0. So power dissipated is equals to 0 in case of a ideal inductor. While coming to a practical inductor, we know the power equation. Power equation. What is the power equation? So P is equals to VI. This is the P is equals to VI. From this, what is the voltage equation here? V is equals to L into di by dt. So P is equals to, what is the value of V here? Since V is equals to L into di by dt, so you can write that L into di by dt into I. Is it correct? So then L into I into di by dt, which is the power equation. So let us take it as a power equation. So this is the power equation. Okay. Now we are going to see the energy stored in an inductor or work done by the inductor. So energy and work both are interlinked to each other. So what is the work? Work is the rate of, sorry, energy is the rate of doing work. So rate of doing work should be calculated by the integration of power. What is that? Integration of power. Integration, we are doing the power integration, integrating the power, we get the work done. So how the work is done? Work is nothing but, energy is nothing but rate of doing work. Okay. So from 0 to time, 0 to t. So we are going to find the work done. So work done is the rate of, power is nothing but rate of work done. Okay. Now see what is the P value? We already know that, since P is equals to L into I into di by dt. So integration of 0 to t, L into I into di by dt into dt. dt gets cancelled. Then what happened? Integral 0 to t L into I into di. Okay. So here L is the constant. So L is what? L is a constant. So that we are going to take the L from out of the integration. So L integral 0 to t I into di. Now by expanding this integration, what should we do? So by expanding this integration, if we do L I square by 2 0 to t, then what happen? If you take this L half into I square 0 to t, I square 0 to t. Now substitute this integration, L into half I square with the maximum limit minus I square into minimum limit. Then what it will be become? L into half I square t, or half L I square. So finally work done is equals to half L I square. So this is all about the inductor. So we will see in this video. In this video, we will see voltage equation, current equation, power dissipated from the inductor, and the work done by the inductor. Okay, these are the things we will see. Now see, let's see what is the reactance. Inductive reactance. Inductance. L is the inductance. Inductive reactance. Inductive reactance. What is this inductive reactance? XL. So this XL is directly proportional to angular displacement, omega. We know that omega equal to 2 pi f. So to remove this proportionality constant, which reactance is this XL? This XL is the inductive reactance. So we are going to consider inductance as a constant. So XL equal to L into omega. Okay. So now XL is equals to 2 pi FL. So this is the inductive reactance. So inductive reactance is nothing but resistance offered for the inductance. Okay.